I think it's fair to say that most volcanologists at some time or other have dreamed of going to Kamchatka. We have a big volcanology and petrology research group in Bristol. We're fascinated by all things magmatic, and that means we're always hungry to explore new volcanoes. In the case of Kamchatka, it's a volcanologist's paradise, and we had the great opportunity to work with a group from Moscow State University and also the Volcanological Institute on the Kamchatka Peninsula. Just getting to Kamchatka was quite exciting. We arrived in the airport in Petropavlovsk and immediately boarded the most enormous truck. And we then drove in total for about 15 hours northwards, and then eventually up the steep slopes of Tolbachik to the campground. In Kamchatka, what we were researching was volcanism associated with destructive plate boundaries or subduction zones, and we're particularly interested in how much water is contained in the Kamchatka magmas. In November 2012, we heard that Tolbachik was erupting again after a dormancy of nearly 40 years, and this was an incredible opportunity to go and see a basaltic subduction zone volcano in action.
Here we are at Tolbachik. Arrived about 10 o'clock last night with a welcome glow. Just behind us is an active fumarole, possibly a lava lake has been suggested, but we'll go and take a closer look today. We're going to do some exploring, see what Tolbachik holds in store as far as volcanic features go.
Tolbachik is a really famous volcano for an eruption that happened in 1975 called the Great Fissure Eruption. It's essentially a basaltic volcano. In fact, the magmas that have come out of Tolbachik are so rich in magnesium that it's entirely possible that they came directly out of the mantle, probably 50 or so, maybe 60, 70 kilometers below our feet, rose up, pausing briefly on the way up to crystallize some, and then ponded in a shallow magma chamber shortly before eruption. So we're looking at magmas now that are largely unmodified by crystallization processes within the crust.
As we reached this part of the volcano, things started to get a little bit hotter. There's a crater, and within that crater was, without doubt, the most exceptional scene I've ever witnessed. Watching the eruption was definitely one of the most amazing sights I've ever seen, but at the same time one of the most frightening for me as well.
You climb up the cinders up to the very edge of the active crater, and you peer over into a sort of a vision of hell, really. Two vents, both filled with small lava lakes, that periodically belch into life, throwing big gobs of magma up into the air, some of which are crashing around you.
So this is the incandescent bomb. It was incandescent, which we collected just on the crater rim after some small burst of the lava lake. So I think it's about 900 or 1000 degrees Celsius.
You can just feel the heat coming off that. Yeah, I can see the incandescent interior.
Mm-hmm.
So the plan is to take that back?
Yeah, this is the question, how to...
On Tolbachik we saw lava bombs coming out of the vent, which is on the flanks of the volcano itself. That vent also fuels a lava flow, and as the lava flows down the flanks of the volcanoes, it develops a hard crust. Periodically, the rocky skin on the surface ruptures, and you get little windows or skylights that allow you to see down into the interior of the lava flow. To see something that was this hot, this active, and this primeval was a completely new experience for me. Lava flows are constantly trying to resist the tendency to solidify due to cooling. This creates a number of very interesting landforms. If the lava in the channel fills the channel up, it can cascade down the flanks, down the levees, producing quite spectacular lava waterfalls.
We are 5 kilometers from the lava source on a bank of a lava river, which is about 1 meter wide and The lava flows with a speed of about 1 meter per second. The lava is still extremely hot and not very viscous, and it forms a big lobe that spreads all around the plain. The complexity of the flow is enormous. It builds up walls by itself, and this depends on the speed of the lava, on the slope, on the possibility of the formation of the crust. Nature is definitely more complicated than we think.
Lava is constantly trying to find new ways to get down the flanks of the volcano. Periodically, the lava builds up within the flow, and the lava is then able to break out. It's able to find a way through the flanks and form new flows at the margins of the older flows.
I think this is one of the most exciting things I've seen in years. It's absolutely fabulous. A couple of days ago, we were looking at lava flows that had solidified, that had frozen. We were speculating about how the textures formed. Here, it's happening right in front of our eyes. We're seeing the development of the very characteristic ropey texture on the surface. As the lava's flowing down a slope, it has that very striated appearance. As the flow slows down, the surface starts to ruckle up a bit like a carpet, and these ropes form, and eventually, as we can see just below us, they start to curve, forming this arcuate pattern. You can hear the really ominous crackling sound as the skin of the lava starts to crack and the hot interior oozes out. I imagine the magma there is about 1,050 degrees, and I'm feeling rather a lot of radiated heat just now. I think we might need to retreat. I think my trousers are about to catch fire.
Visiting Kamchatka will stay with me for a very, very long time. There are many, many more volcanoes in Kamchatka. There are 29 alone that are active, and I'm hoping it will be the start of a long-term collaboration with Russian scientists. What's great about volcanology is that we are being offered clues as to how our planet works. And the excitement comes in unraveling those clues, deciphering the information that comes out of volcanoes in terms of processes that are taking place beneath our feet. To experience something this exciting early in your career is likely to fuel a long-term passion for volcanology. I would defy anyone to see the kinds of volcanic phenomena we saw on Tolbachik and not be inspired.